Okay, now let's start the last section, which is 2.5 worksheet 4. And this is whenever you graph the function and you see absolutely nothing on the graph. But you know it's degree 4, and you say there has to be 4 roots. Well, if it's degree 4 and you see nothing on the graph anywhere, and you've checked your P over Q values and you checked your Descartes, and you're like, okay, this means they're all imaginary. If they're all imaginary, you can't see them. So how do I come up with them algebraically if they're all imaginary and I can't physically see them on the graph? Well, you know it's degree 4, so that means there's going to be 4 roots. So root 1 is given, so I know root 2 because it has to be its conjugate. So its conjugate is -1 minus 4i. So this is where you need to make sure you have your calculator up. And we are going to go ahead and start this problem. So I'm going to change my pen color, and I'm going to do synthetic division at -1 plus 4i. This is going to be a 1, a 2, a 26, an 18, and a 153. And I am just going to pull this down here. I'm going to cheat a little bit. It doesn't want me to do this though. Okay. Now, what this means is we are going to go ahead and we're going to do some calculation here. So if I do that, the very first thing I want to do is I want to go ahead and pull up my graphing calculator, and I want to start doing the calculation. So I'm going to drop down the 1. Multiplying diagonally, I'm going to have a -1 plus a 4i. This is going to give me a 1 plus a 4i. At this point, I need to then go ahead and bring up my graphing calculator. So if I do that, I am going to have my calculator down here, and I have -1 parenthesis, -1 plus 4i, and then that's going to be times 1 plus 4i, and hit enter. And that's going to give me -17. So I'm going to put -17 right here, and then I'm going to add that to it, and that's going to give me a negative, sorry guys, it's very loud, a +9, sorry. Multiply on the diagonal, this is going to be -9 plus a 36i. And I'm going to show you that on the calculator here as well, so that you can see this. Because I'm simply going to take this number, and I'm going to add 26 to it, and it gives me the 9. Then I'm going to go ahead and multiply that by the -1 plus 4i, and hit enter, and that gives me that calculation. And what I'm just simply doing is checking my calculation will work every time. So if I add 18 to that, I'm going to get the 9 plus the 36i, which you could have already done, okay, in your head. And then I'm going to take that and I'm going to multiply that by the -1 plus the 4i, and hit enter. And that gives me the -53. So if that gives me the -53, then that gives me 0. So now that I've done it the first time, it's pretty easy for us. So we're going to go ahead and do synthetic division at the next root, which is going to be -1 minus 4i. And I drop this down and I multiply. That's -1 minus 4i. That cancels out and that cancels out to give me 0. 0 times anything is 0, which gives me a 9. Then I go ahead and make that multiplying -9 minus 36i, and that gives me a 0. Okay, that's perfect. Because now this is going to become degree, it was 4, so degree 3. Doing it again makes it go from degree 3 to degree 2. So now what you have left is an x squared plus a 9, and that's equal to 0. How do I solve this? Well, there's several options. You can do the quadratic formula. You can factor it, which it's not going to be factorable because they're going to be imaginary roots. Or you can simply subtract 9. Take the square root of both sides, and when you take the square root of -9, you're going to get plus or minus 3i, which means the complete factored form of this, where I'm going to have root 3 be 3i, and root 4 going to be -3i, is going to be x plus 3i, x minus 3i, x plus 1 minus 4i, and x plus 1, plus 4i. It's very hard to see on this. And that is how you're going to do problem 1. Now you need to do problem 2 exactly the same way.